Hi everyone, today we are going to work on composition of trig values. We have learned about composition of functions before. When we have f of g of x like this is basically f of g of x. If I want to evaluate this function, first I need to evaluate the inside function g of x, then I put the answer here as the input of f, and then we evaluate f of whatever is this answer. So this is how we work on composition of functions. The same way we can work on composition of trig values, trig functions. For example, here we have secant of sine -1 of 5/7. To solve this, I'm going to consider this one as f, the outside function, this one as the inside function. So this is f of g of 5/7. So first I evaluate the inside one, then I go to the outside. So to solve this problem, I'm going to start with sine -1 of 5/7. First of all, let's find this one. Okay, so to solve this, I'm going to say sine value is a positive value. So that means the angle should be either in the first quadrant or the second one. But the restricted range for sine -1, based on what we have learned before here, for sine -1 is between -pi/2 to pi/2. So I can take this one. It's not in the restricted range. Let me write it here for you. It's not in restricted range, so we don't take this one. We're going to take only this one. Okay, so here's my reference angle and the right triangle. Sine is opposite over hypotenuse, so the opposite is 5 and hypotenuse is 7. Now I can use the Pythagorean theorem to find this side. So let's call that x squared. This side, let's call that x. So x squared is 7 squared minus 5 squared. 49 minus 25 is equal to 24. So x will be square root of 24. I can simplify square root of 24 as 2 root 6. So this side is 2 root 6. Okay. Now I need to find sine -1 of 5/7. How do I find that? This is not a special right triangle, so I cannot easily guess the angle. Guess what? We don't even have to do that, because what is the question here? The question is asking us to find secant of this value. We know that secant is 1 over cosine. Cosine is adjacent over hypotenuse, so secant will be hypotenuse over adjacent. So that's all I need here. When I have my right triangle, I'm just going to take the hypotenuse, which is 7, and the adjacent, which is 2 radical 6. And that's my answer. So the good thing about this kind of problem is that we don't have to go back and find the angle. Once I have my right triangle, I'm just going to use the ratio of the sides to find the secant here in this example. Okay, so let's work on this one. Arcsecant of -3/2 is the inside. So I'm going to work on this one first, which is basically secant -1. Arcsecant is the same as secant -1. Okay, so secant is a negative value. How do I know where's my angle? So I'm going to use the rule for secant. We know that secant is 1 over cosine. So whatever is the sign of secant, the same is cosine. If this is positive, cosine is also positive. Negative, this is also negative. So if here I have secant -1 of -3/2, secant is negative, that means cosine is also negative. And we have learned before that if cosine is negative, then the angle is either in the second quadrant or in the third one. So it's going to be either here or here. Now, which one should I accept? The restricted range for secant was, for secant -1, was from 0 to pi. So that's the restricted range. So I can accept the ones which are between 0 and pi, not this one. So this one is not in of restricted range. We're not going to take that, only this one. So I have my reference angle and the right triangle. Secant is hypotenuse over adjacent. So this is my hypotenuse, this is the adjacent. Hypotenuse is 3, adjacent is 2. The negative goes with the side because hypotenuse is always positive, and this is on the left side, so it's negative. Now I can use Pythagorean theorem to find this side. I can say x squared is equal to hypotenuse squared minus adjacent squared. So it's 9 minus 4, which is 5, and x will be square root of 5. So this side is square root of 5. Now, what is secant negative 1 of negative 3 over 2? What is the angle? It's not easy to guess because we don't have a special right triangle here. And once again, we don't even have to find that because all I need here is cotangent, which is opposite over adjacent. If I have the opposite and adjacent side, then I'm done. Opposite side is root 5. Oh, I'm sorry. Cotangent was adjacent over opposite. So adjacent side is negative 2, and opposite side is 5, root 5. So that's my answer. Okay, now let's go to next example. These examples are a little bit different from this one. The main difference that you see here is that on top one here, the inverse function is inside, but for this one, the inverse function is outside. So the way we solve is a little bit different, but the basics is the same. That means we have a composition function, and we start with the inside first. So first of all, I need to find what is sine of 4 pi over 3. How do I find this? First, find the angle. Where is the angle located? Well, this is 0 and this is pi. Because the denominator is 3, I'm going to change this to 3 pi over 3. Now, 4 pi over 3 is a little bit after 3 pi over 3 is going to be here. If you're not sure about that, you can find it in this way. You say, if I make a full circle, this is going to be 2 pi, or basically 6 pi over 3. Halfway from 3 pi to 6 pi is 4.5 pi over 3. So 4 is between 3 and 4, so it's going to be here. Okay, so my angle is going to end at this point, and this is my reference angle. This is 4 pi over 3. The reference angle is going to be 4 pi over 3 minus 3 pi over 3, which is pi over 3. So I found my reference angle, which is 60 basically. So I have a special right triangle, 60, 30, and 90. The ratio of the sides are 1, root 3, and 2. This is negative, and this one is also negative because it's left side and below the x-axis. Okay, so what is sine? We know that sine is opposite over hypotenuse. If I find the sine value of this angle, that's basically my answer. So opposite is negative root 3 and hypotenuse is 2. So we found the answer of the inside. So what I have here now is cosine negative 1 of, so instead of this, I'm going to write the answer that I just found, radical 3 over 2. Now I have a new question. Now I need to solve that. For this new question, I need to have a new shape as well. So we are looking for cosine negative 1 of negative root 3 over 2. This is what I need to find next. Okay, so I'm going to say cosine is negative, so the angle should be either on this quadrant or this one. What was the restriction for cosine? Let's go back here. For cosine, restriction is from 0 to pi. So I cannot take this one, not in the restricted range. So I have to take only this one. This is my reference angle and the right triangle. Okay, cosine is adjacent over hypotenuse. So adjacent is radical 3, hypotenuse is 2, and the negative goes with this one because hypotenuse is always positive. Now I can use the Pythagorean theorem and I will see that this side is equal to 1. So we have a special right triangle of 30, 60, 90. Opposite 1 is 30 or pi over 6. So our reference angle is found is pi over 6. Now what is my original angle? We learned that before here again. If the value is negative, like this one, the answer is in the quadrant 2, and the answer is pi minus the reference angle. So we're going to take pi minus the reference angle, pi minus pi over 6. So find the common denominator, 6 pi over 6 minus pi over 6, because we put the denominator of 1 and we multiply top and the bottom by 6. So it's equal to 5 pi over 6. And this is our answer, 5 pi over 6. Oops. Okay. Now the next one. Again, I'm going to solve the inside first. Cosine of 3 pi over 4. So find the angle first. This is 0, this is pi, which I'm going to change it as 4 pi over 4. 3 pi over 4 is a little bit before that, because I know that halfway from 0 to 4 pi is 2 pi over 4. So 3 pi is between these two. Okay, so this is 3 pi over 4. 3 pi over 4. Now the reference angle is 4 pi over 4 minus 3 pi over 4, which is pi over 4. And pi over 4 is basically 45. So the triangle that I have here is 45, 45, 90. The ratio of the sides will be 1, 1, and root 2. Which one is negative? This one. This one is negative because it's on the left side. Okay, so cosine is adjacent over hypotenuse. Adjacent side is -1, and the hypotenuse is root 2. So we found this part. What do we have now? We have sine -1 of -1 over root 2. Now we have a new question. I need to have a new picture here as well. So sine -1 of 1 over -1 over root 2. Okay, sine is negative, so it should be either here or here. And the restricted range is between -pi over 2 to pi over 2. So this one is not accepted. We take only this one. Okay. Sine is opposite over hypotenuse. So opposite is -1, hypotenuse is root 2. Use the Pythagorean theorem, this side is 1. So the special right triangle of 45, 45, 90 is seen here. This is pi over 4. Now, we found the reference angle. What is my original answer? Let's go back here. We already learned that if the value is negative, the angle is in the fourth quadrant, and the theta will be negative of theta reference. So the answer is negative of theta reference, which is negative pi over 4. So the answer is negative pi over 4. Okay, I'm going to do one more example for you, which is not in your notes, but it's good to practice this one. Cosine -1 of tangent of 0. So we need to find tangent of 0 first. So that's the first thing, tangent of 0. Where's this angle? 0 is here. It's a quadrantal angle. So when I have a quadrantal angle, I'm going to use the coordinate of this point. And this point, if I consider this is on the unit circle, this point will be 1 and 0. This is my x and y, and we know that this is sine and this is, oh, I'm sorry. The first one is cosine and the second one is sine. And we know that tangent is sine over cosine, or we can also say y over x. This is y and this is our x. So it's equal to 0 over 1, which is equal to 0. So we found the inside. It's equal to 0. We have cosine negative 1 of 0 now. This is what we need to find. Okay. So there is an angle that cosine of that angle is equal to 0. We know that in this case, we are not able to make a triangle, so we need to consider the quadrantal angles. We know that cosine is the x value. So if I have the coordinates, this one is 1, oh, I'm sorry, this one is 0 and 1, negative 1 and 0, 0 and negative 1. Okay, so I need to look for a x value which is equal to 0, and that's this one and this one. One of these two are my answer. Which one is my answer? This one, because cosine negative 1 has a restricted range. Cosine negative 1 is between 0 and pi. So I cannot take this one. This is not in the restricted range. So this is my answer. Now, what is the angle? It's pi over 2. And that's my answer. Okay, so this was today's lesson. Have a great day.